In the previous video, we introduced the term DOM for Document Object Model, but we didn't do much more than that, so it's probably still pretty much a mystery. In this video, we explain the essential concepts behind the DOM and how to apply them to JavaScript event handlers. This is where the real fun begins. Documents can be broken down to pieces or parts called nodes. The DOM standard recognizes 7 types of nodes, but we only care about these. The document type node, specified as the reserved word document, it represents the whole HTML file, and there is exactly one per document. The document type node, specified as the doc type statement, there's only one per document. A comment type node, identified by less than, exclamation point, dash dash, and ending with dash dash greater than. There may be 0 or more of these in a document. An element type node, identified by tags. There is one root node, the HTML node. The HTML node can have 2 child nodes, head and body. These are element type nodes also, and they can have 0 or more child nodes themselves, of type element, comment, or text. And a text type node, the textual content of an element. These can have no child nodes. And the vast majority of our interest lies in the document, element, and text type nodes. A node is an object. It has properties and methods. Basically, a node's properties are things like the node type we've just discussed, and identification of the node's parent node and its child nodes, and so forth. A node's methods are the actions you can take to create, modify, or delete nodes, and in the case of element type nodes, the available methods allow you to add, delete, and modify the attributes of an element. A specific document. We shall talk in the general sense, but it is helpful to also have an explicit example to use in our discussion. So let's start with this. Doc type HTML, copyright statement, and the HTML header, and a head with a title, all meeting spaces, a style element with 2 style rules in there, and the end of the head. Then the body, which begins with an H1 element, home office, and an H2, 3 lines of text for an address, and a pre-formatted element, ID of list _1, and there's style information, and the content is meeting spaces, max capacity, and then we have a list of a conference room A and conference room B with a link to a picture about those. This document contains the following nodes, and we'll analyze this and use a diagram to help clarify. A document type node, the doc type statement. A comment node. Any document may have 0 or more comments. An element node, the HTML node. Every HTML document has 0 or 1, but why would you want 0? This single node is called the root of the document. Now, structurally, we look at what is included under, nested within, the root element node, what are called child nodes. And we see the HTML node has 2 child nodes, head and body. These are both element type nodes. The head node has 2 child nodes, title and style. The title node has a single child of type text, and the style node has a single child of type text. The body node has 3 element type child nodes. The H1 node has a single child node of type text. The H2 node has 3 child nodes of type text and 2 child nodes of type element. The pre node has 3 child text nodes and 2 child element nodes, the A nodes, and each A node has a child text node. Now, in this context, take a few seconds to reflect on what may be meant by these terms. Some properties for all nodes: node type, parent node, first child, last child, previous sibling, next sibling. And some methods for all nodes: replace child, remove child, append child, and has child nodes. Note that property and method names are case sensitive. They must be capitalized as shown. An important attribute of elements is the ID attribute. It is one of the global attributes, and we have mentioned it consistently. We reference the value of an element's ID attribute in order to access the element in a script. Remember, all ID values in a document must be unique within the document. To access an element of a document from JavaScript, you invoke the GetElementById method on the document node. You actually code document.getElementById and in parentheses the value of the ID you're referencing. And this invocation of this method on the document object returns the specified element node, or null if there is no such element. Where does it get returned? Into a variable. Maybe myList equals document.getElementById parenthesis listhead. So now the variable myList contains, from our previous example, the UL element node, and we can work with properties and methods on this node. Let's look at some tools, a few of the methods available for the document node. Create element, create an element node. Create text node, create content for a text type node. And getElementById returns the element with the specified ID value, or null if there is no such element. There are more, but these will be plenty for our needs. Generally speaking, a method identifies an object and an operation to perform in that object. A method takes some input information, 0 or more arguments, performs the operation using that information, and possibly returns an output value. The returned value may be captured in a variable using an assignment statement, or may be ignored. An error might be raised when invoking a method. For this course, we shall ignore handling such errors, which implies you need to be especially careful in designing your code. Here's the general syntax for methods performed on the document node object when you want to capture the return value. Variable equals document dot, method name and parenthesis arguments. The number of arguments required, the type of each argument, and the value returned from each method are all well defined, and we describe them when we discuss particular methods. Now, when a method returns an object, such as a node, as with the getElementById method, that object in turn will have properties that can be accessed and methods that can then be run. For example, after executing this statement, myList equal document.getElementById listhead, the variable myList contains an object reference to our UL element, which is an element type node. So we could, for example, take that object in an assignment statement such as myList.style.color equals red. Or, more interestingly but more complicated, we can combine the two statements into one. Document.getElementById listhead.style.color equals red. So let's look more closely at the methods we mentioned above, which are available to the document node. Create element. For its input, you put a tag name. For example, some tags we've worked with so far, P and IMG and A and LI and so forth. Either put it in a variable or as a string literal. It's case insensitive. The output of this method is an element of the specified type. Now the element starts out empty. It takes more work to populate it. For an example, new entry equals document.createElement li. Create text node. Input is the text to be included in the node, a string expression, and the output is a text node with a specified content. For example, New text equals document.createTextNode, parenthesis quotes, third name in the list. GetElementbyId, the input is the value of the ID attribute of an element, that is a string expression, and the output is the element with that ID, or null. For example, myList equals document.getElementbyId, parenthesis listhead in quotes. So, to reference elements and or attributes from a script, if the reference is to the element containing the script, you can use the reserved word this, like we did in the previous video, this.style.color equals red. But if the reference is to an element not containing the script, you need to use the document.getElementbyId method. But this resolves to just the node. To change the value of an attribute of the element, you need to qualify the node with a period followed by the attribute name. For example, document.getElementbyId parenthesis conf.a.src equals conf_a.jpg. And if the attribute you want to change is style, you need to append a period followed by the style property. For example, document.getElementbyId parenthesis phone.style.color equals red. Note that a text type node can't have an ID since it is the content of an element, neither an element nor an attribute. In this case, we can use the first child property that is available for all nodes. For example, document.getElementbyId parenthesis par1.firstChild, and this returns a node which then has the usual properties and methods available. Here are some useful properties available to all nodes. These are all read-only. You can't change them in a script. Node type. It's an integer. It's a value of 1 for element nodes, 3 for text nodes. We're not going to look at the others. Parent node. It's the node above the selected node on the document tree. Null if there is no parent or if the node is just being created and not yet inserted into the tree. First child. The first child below this node, or null. Last child. The last child below this node, or null. Previous sibling, the node immediately preceding this node, or null. And next sibling, the node immediately following this node, or null. Here's some examples. var1 equals document.getElementbyId list_1.nodeType, and that returns 1 into var1. var2 equals document.getElementbyId list_1.parentNode, returns the body element into var2, since the pre-element's parent is the body. var3 equals document.getElementbyId list_1.firstChild, returns the text node containing meeting spaces : max capacity into var3. var4 equals document.getElementbyId list_1.lastChild, returns the text node containing 10 knitting room 5 into var4. var5 equals document.getElementbyId of list_1.nextSibling, returns null into var5. var6 equals document.getElementbyId list_1.firstChild.nextSibling, returns the first A element node into var6. var7 equals document.getElementbyId list_1.previousSibling, returns the H2 element node into var7. But var8 equals document.getElementbyId list_1.lastChild.previousSibling, returns the second A element node into var8. Next, some methods that are available for all nodes. Append child. Place a child node after the current node. Replace child. An existing node is replaced by a new node. Remove child. A node is removed from the document. And has child nodes is a Boolean value. It's either true or false. So, append child. Its input is the node to append to the current node. The output is ignored, but the result is the node is inserted after the current node. For example, new entry dot append child new text. Note, if you don't catch the output of the method, no variable equals, it is simply ignored. The method still runs, however. Replace child. Input is new node and existing node. Output is ignored, but the result is the new node replacing the existing node. Example, mylist.replaceChild, parenthesis, new entry, comma, last entry. Remove child. The input is the child node to delete, and the output is ignored, but the result is the child node is deleted. Example, mylist.removeChild, parenthesis, old entry. Has child nodes. The input is nothing, so you code it as parent, and the output is simply true or false. For example, go ahead equals mylist.has child nodes, parent. Note, these are just demonstrations of syntax. We'll look at some applications for some of these shortly. Related, here are some important methods for all element type nodes. GetAttribute. The input is the name of the attribute, a string expression, and it returns the value of the attribute. For example, dest equals document.getElementById link01 dot getAttribute href. So it returns the href attribute value for the element with an ID of link01. SetAttribute. The input is the name of the attribute and the value to set as string expressions. And note, for Boolean attributes, code the attribute name for both inputs. The output is ignored. This method adds the attribute if it's missing and changes the value if the attribute is already there. For example, document.getElementById parent v1.setAttribute parent src, gizmo.mp4. Remove attribute. The input is the name of the attribute, a string expression. The output is ignored. It removes the attribute. So for example, document.getElementById parent p1.remove attribute hidden. Finally, we look at a property and a few methods that apply to the content of a text type node. Property length returns the number of characters in the text node. Methods substring data, and your arguments are the offset and the count. It returns the characters in the content. Offset is an integer. The first character has a 0 offset. Count is an integer. Append data and a string expression. It adds that string expression to the end of the current content. Insert data. The arguments are offset and string expression. Basically, you insert that string expression into the content beginning at the specified offset. Delete data, offset, comma, count, removes a substring from the content. And replace data, offset, count, string expression. It replaces the content found at the offset for the given count with the value of the string expression. Notes on text node methods. Offset and count above can be integer constants or variables or arithmetic expressions that resolve to integers in the right range, that is, from 0 to the maximum location. A few words about strings in JavaScript. A string literal is a string of characters bounded by double or single quotes. For example, double quote, here I am, double quote, or single quote, this is you, single quote. A string of characters not bounded by quotes is considered to be the name of a variable. So if you code document.getElementById parenthesis the ID, JavaScript thinks the ID is a variable, and you want the value in the variable to be the string you're searching on. For example, given var1 equals quote cust underscore name, semicolon, then document.getElementById parenthesis var1 will get the same results as document.getElementById parenthesis quote cust underscore name quote. A string expression is a string literal, or a variable, or a series of string literals and variables connected by plus, the concatenation operator. For example, full name equal first name plus quote space quote plus last name, or search name equals last name plus quote comma space quote plus first name. If you have a string bounded by double quotes, which is pretty standard for event handlers, then nested string literals must be bounded by single quotes, because a double quote would terminate the outer string. And if you have a string bounded by single quotes, then apostrophes cause a problem, because it is really the same character. Document.createTextNode parenthesis quote I don't like it is a problem. To embed an apostrophe, you need to use a backslash character. To escape the apostrophe, the presence of the backslash tells JavaScript that you are not using this as a string terminator, but as a literal. Document.createTextNode parenthesis quote IDON backslash apostrophe or quote like it, close quote, close paren, semicolon. Let's look at some sample JavaScript. Here's a paragraph tag with an ID of p3 underscore 0, and it says on click document.getElementById p3 underscore 0 dot first child dot append data exclamation point. So notice the ID is its own self. Clicking this line appends an exclamation point. Another p tag, ID is p3 underscore 1. On click, document.getElementById p3 underscore 2 style.color equal fuchsia. Clicking here changes the color of the line below. And indeed, the next paragraph has an ID of p3 underscore 2. And here, in onClick, we assign a variable more equals quote space yuk quote semicolon. That's the first JavaScript statement in this event handler. And then this dot first child dot append data parenthesis more, which is the variable we just defined. This line should grow each time it is clicked. So notice the use of this in this last example. It could also have been used in the first example, but not in the middle one. So to work with a text type node, you need to access its parent node and then access the appropriate child node, then apply one of these methods. It's hard to comprehend the power of these tools until you have an actual opportunity to use them. But you can add and delete and modify elements in your web page based on user actions, clicks, and mouse movements and keyboard entry. And it usually takes a series of these commands to accomplish something useful or interesting, so just looking at the syntax and one-line examples doesn't help, except to see how the statement might look. Let's try one more example. Set up a P element that, when clicked, will add an LI element to the unordered list with ID listhead, based on these lines of code we saw earlier. UL ID equals listhead, LI ID equals name1, first name in list, end LI. LI ID equals name2, second name in list, end LI, end UL. So the code goes like this. P on click equals new entry equals document.createElement parenthesis quote LI quote paren. new text equal document.createTextNode, parenthesis third name in list, new entry dot append child new text, document.getElementById headlist dot append child new entry, and on click. Click to add list entry. What's happening? We create a new empty element of type li, then we create a text node with third name in list as content, and we put the text into the li element, and we add the new I element to our unordered list. My brain hurts. I understand. Lots of details in a short amount of time. Let me try to summarize the highlights. Maybe that will help. The DOM, Document Object Model, describes an HTML document in terms of nodes, which are objects that have properties and methods associated with them. For our purposes, we care about document type nodes, element type nodes, and text type nodes. We mentioned doc type and comment type nodes in passing. We did not discuss properties of the document type node. These methods apply to the document type node. Document.getElementById with an argument returns an element node. Document.createElementTagName returns a new node of the type specified by tagname. And document.createTextNode and then a string expression returns a text node. Now these properties apply to all node types. Node.nodeType returns an integer, 1 for element type, 3 for text type. Node.parentNode returns a node, first child returns a node, last child returns a node, previous sibling returns a node, and next sibling returns a node. These methods may be used by all node types: append child, replace child, remove child, and has child nodes. We did not discuss properties of element type nodes, but these methods may be used for all element type nodes. Get attribute, and you specify the name of the attribute, and it returns the value. Set attribute, specify the attribute and its value, it returns void. And remove attribute, specify the name of the attribute, and it returns void. This property applies to text type nodes, node.length. It returns an integer. These methods apply to text type nodes. Substring data, and you say from where for how long. Append data, put a string expression, it returns void. Insert data, beginning at an offset, insert this string expression, it returns void. Delete data, beginning at offset, delete this many characters. And replace data, beginning at this offset, for this count, insert this string expression to replace what was there. In the next video, we look at more sample code using DOM, and we find some helpful debugging tools that use the document node. See you there.